for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on solubility as an equilibrium process. We have had a few lessons so far on this topic. This will be the final one. In our last lesson, we learned about determining the solubility of substances. We discussed the solubility of table salt and sugar. In today's lesson, we will learn about the effect that pressure has on the solubility of gases. We will state Henry's law and we will use it to calculate concentration of a gaseous solute in a solution. If you are ready, we will begin. Pressure significantly affects the solubility of gases. However, it has little or no effect on liquids and solids. This is because liquids and solids are almost incompressible, whereas gases can be easily compressed. The solubility of gas always increases when the pressure exerted on it rises. The effect of increased pressure on the solubility of gases has been used by the beverage industry for a long time. Different bottled and canned drinks such as soda, beer, and champagne are bottled under carbon dioxide pressure up to 4 pascals. The measurable relationship between pressure and gas solubility is explained by Henry's law. Henry's law states that at a given temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure. In this equation, C subscript G is the molar concentration of the dissolved gas in moles per liter, and P subscript G is the partial pressure. K subscript H is Henry's law constant. This is expressed in moles per liter atmosphere. Students, please describe why the solubility of gases is affected by pressure, whereas the solubility of liquids and solids is not. Also, please state Henry's law.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I hope that activity was a good review of what we have learned thus far in our lesson today. The solubility of gases is affected by pressure because gases are easily compressible, whereas liquids and solids are almost incompressible. Henry's law states that at a given temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas over the solution. Let us continue with our lesson by discussing an example. Students, in this image, we can see a piston cylinder assembly in which there is a gas above a saturated aqueous solution of the same gas. At a given pressure, which is represented as P1 in image A, the number of gas molecules that enter and leave the solution per unit time is constant. This means that the system is at equilibrium. If the piston is pushed down and the pressure is increased, such as in P2, the volume of the gas decreases. When this happens, the gas particles begin to collide with the liquid surface more frequently. As a result, more gas particles begin to enter the solution per unit time. Therefore, when the gas pressure is increased, the balance of equilibrium is disturbed. More gas dissolves in order to reduce this disturbance, which continues until the equilibrium is re-established in the system. Students, let us do an activity. The partial pressure of helium inside an enclosed container of water is 4 atm at 20 degrees Celsius. Henry's law constant for helium in water at this temperature is 3.7 times 10 to the negative 4 moles per liter atmosphere. What is the solubility of helium?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Did you find this activity to be difficult? Let us go through the steps together so that you can check your answers. We know that the pressure over the helium is 4 atmosphere, and we know that Henry's law constant for helium is 3.7 times 10 to the negative 4. To find the solubility of helium, we simply have to multiply the pressure over helium by Henry's law constant for helium. Therefore, we multiply 3.7 times 10 to the negative 4 by 4 atm. And the solubility of helium is 0.00148. Students, let us try one more activity. The Henry's law constant of methyl bromide, a gas used as a soil fumigating agent, is 0.159 moles per liter standard atmosphere at 25 degrees Celsius. What is the solubility of methyl bromide in water at 25 degrees Celsius at a partial pressure of 0.164 standard atmosphere?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope that you did not find this activity too difficult. We begin with the formula that we discussed previously, and we insert Henry's law constant for methyl bromide, as well as the atmosphere for the partial pressure of methyl bromide in water at 25 degrees Celsius. We then multiply the two together, noting that the ATM gets canceled out as it is on the top and the bottom. Therefore, the solubility of methyl bromide in water at 25 degrees Celsius with a partial pressure of 0.164 standard atmosphere is 0.0261 moles per liter. If you answered correctly, well done. If not, please review your notes and ask your teacher for extra help after this lesson. In today's lesson, we learned about the effect that pressure has on the solubility of gases. We learned that pressure always increases the solubility of gases because they are easily compressible. We also learned about Henry's law and used its constants in order to calculate the solubility of gases in a solution and the concentrations of a gaseous solute in a solution. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.